All right, guys, this is Algebra 2. We're starting with video 1.1. Today we're going to be talking about sets of numbers. All right, we're going to be talking about classifying numbers. That's what we're going to start with because the number system is already separated out into certain sets of numbers. What we're mainly going to be dealing with are real numbers. You need to know all of these types of numbers. You need to know what kinds of numbers go in them, and you need to know their symbols. So a symbol for a real number is going to be this double lettered R, okay? A real number, pretty much any number you can think of is going to be a real number. If there are real numbers, that means that there are non-real numbers or imaginary numbers. Not sure how much we'll get into that in Algebra 2. We definitely do it in pre-cal. So real numbers can be broken down into two sets. You have rational numbers. A rational number is going to be, example would be a fraction that does not reduce down to a whole number. There's decimals that repeat and decimals that end. So like 1/2 would be a rational number because if you were to change that into a decimal, you would get 0.5. It is a terminating decimal, so that makes it a rational number. So rational's symbol is going to be a Q. The opposite of rational is going to be irrational. An irrational number is going to be basically a decimal that doesn't end and doesn't repeat. And it can come in a variety of ways. It can look like a fraction where if you were to divide the top by the bottom, then you would get a decimal that moves on and on. Most commonly irrational are going to be square roots of non-perfect squares. So the square root of 9 would not be irrational because the square root of 9 is 3, which makes it rational. The square root of 2 or the square root of 3 or the square root of 5, those would be irrational. If you put them in your calculator, you will get a decimal that continues on and on. Another example of an irrational number is pi. We like to say pi is 3.14, but it's actually a decimal that continues on and on. They don't know where the ending is, so we say that it is irrational. I'm not going to give you a symbol to indicate irrational numbers. So for now, if it's an irrational number, we're not going to worry about that. We'll just write the word irrational out. Next, underneath rational are going to be integers. Integers are going to either be positive or negative whole numbers. And the symbol for an integer is going to be a Z. Now, if you see all of these typed out, your Q would actually be kind of like a doubled, and your Z would be like doubled. But that just looks messy on my screen, so I'm not going to do it that way. So Q and a Z. Integers would be like a -1 and a +1. Those would be types of integers. Now, not decimals. They have to be whole numbers. Because if they were decimals, they would not be integers. They would be rational numbers. After integers are going to be whole numbers. And their symbol is a W. Now, whole numbers are going to be anything that is positive. 0, 1, 2, 3, 4, 5. So the biggest difference between a whole number and an integer is going to be that negative out in front. So if you have a negative number, then it's going to be an integer. If it's a positive, starting with 0, then it's going to be a whole number. So 0 is going to fit in right here. And then the other ones, we call them natural numbers or counting numbers. So your natural numbers, their symbol is going to be an N. And your natural numbers are going to be a 1, 2, 3, 4, 5, continuing on and on and on. All right. Now, what's interesting about this is if you take a natural number, let's say we are looking at the number 5. It is a natural number. It is also a whole number. It is also an integer. It is also a rational number, and is also a real number. So when we classify them, we are going to go from our smallest. You want to go to the smallest thing, subset that it's in, and it's in everything that's outside of it. But if we're looking at 0.13 repeated, let's say that's the number we're looking at. That is not a natural number. It is not a whole number. It is not an integer. Its lowest subset that it would be is a rational number and a real number. If we're looking at pi, that would be an irrational and a real number. All right. So when you classify them, you want to find the smallest set that it is, and once you find that, it's everything outside of that as well. Let's do some practice. So I have these numbers here. We have 0.6 repeated, square root of 2, 0, negative 5 halves, and 0.5129. So we are going to order these numbers. We're going to order them from least to greatest. And then after we order them from least to greatest, then we will classify each of the numbers, right? So in order to do that, they all kind of need to be in the same form. Because off the top of my head, I don't know what the square root of 2 is. So what you're going to want to do is you're going to find out what each one of them. Going to a decimal is about the easiest way. So we've got a 0.6. So we're going to leave that as a 0.6 repeated. The square root of 2, if you put that in your calculator, you get 1.414 or so. Negative 5 halves, that would be negative 2.5. And then this is already a decimal as well. All right, so if we're going from least to greatest, thinking about the number line, our negative number is going to be the smallest. So we would start with negative 5 halves. And then, oh, I left my 0 out of there. Next would be 0, and then radical 2, because that is 1. Nope, that's not right. Okay, so after 0 is going to be 0.5129. After that would be 0.6 repeated. And then it would be square root of 2. So now let's classify them. So negative 5 halves is a fraction. What we got to think about is, does it repeat or not repeat? So we go back to where we looked at it, negative 2.5. It is a terminating decimal. So if it is a terminating decimal, that means that it is a rational number. So I'm just going to draw it like this. So I'm going to say that it is a rational number and a real number. My 0, the smallest we can do, is not a natural counting number. It starts with a whole number. So we would say the 0 is a whole number, an integer, a rational number, and a real number. This one is a terminating decimal, so we would say that it is rational and real. This one is a repeating decimal, so we would say it is a rational and real. This one actually doesn't terminate, even though we stopped it at that 4, it doesn't actually terminate. It is the square root of a non-perfect square, so we would say this is irrational. And if it is irrational, then it has to be real. So all of these numbers are going to be real because that's what we're working with, our real numbers. When we represent our sets, there are several ways we can do it. We can do it with words. If we were talking about the balls on a pool table, we could say billiard balls that are numbered 1 through 15. Okay. You can also do roster notation. So roster notation is going to have the little brackets there that have the little beak on them. So if we were doing roster notation of our billiard balls, we would say the roster is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, and then you want to close your bracket. So when you're looking at sets, you've got to decide if they're going to be finite, which means that there's an ending. A finite set, like the billiard balls, it has a definite end. Or it can be infinite, which means you don't really know where it begins and you don't know where it ends. So if you have an infinite set, we would say that it is unlimited. The other way that you can, the way you take an infinite set is you can say, well, you can do either one of them, is an interval notation. So the two types that we're really going to use are going to be roster notation and interval notation. So interval notation is going to use certain symbols. So you need to know what these symbols mean. All right, so the bracket like this, if you were going to use that, those brackets mean that you include the numbers represented. And if you use parentheses like this, then the numbers are excluded. So I'm going to call them the endpoints. Your endpoint is excluded. So if we were going to do our billiard balls with interval notation and we're wanting to include 1 and include 15, we would say 1, 15 with that bracket. That means that the 1 and the 15 are included. Let's say we were wanting to not include them. In that case, we wouldn't use 1 and 15. We would do our parentheses and we'd say 0 and 16. Because that means the numbers that are in between there, that are in between 0 and 16 but don't include 0 and 16. All right? The other way you can do them is on a number line. So let's practice writing in interval notation. So we are going to represent each set of numbers. All right, so we have an x, and our x is greater than or equal to 4, and it is less than 6. So if you're looking at your sign right here, that is equal to, so we know that we need to use this kind of bracket. We're going to include the 4. The 6 is not have an equal to, it is not included, it is excluded. So we would put comma, 6, and then the parentheses to close it. So you can combine the two types of notations. So on this number line, we actually have two different sets that are represented, so we'll have to work each of them separately. So on the number line, we're going to start with this part right here. Our -5 is included and our -2 is included, so we would say -5 to -2 included. On this side, we have 3, and it's going to on and on and on. It doesn't stop. So what do we call that? We would call that infinity, right? So when we do our interval over here, I'm going to say and, because it's both of these. I'm going to do the parentheses because the 3 is not included. So we'll say 3 to infinity. And infinity is not an actual number. It just indicates that it goes on and on. So we are not going to include it. We are going to exclude it and put the parentheses cap on the end. The other way you'll do it is set builder notation. All right. So you need to be able to read these. So basically, like if you just looked at this, this is what upper level math looks like, right? This is a sentence written in mathematical terms, but you got to be able to know what it says. So the way you read this is it actually says the set of, so the set of is the brackets. That is roster notation, it is the set, okay? Of all numbers x, that's where your little x is there. If it was something other than x, then your sentence would read something different. This line means such that, and then this indicates that the x is greater than 8 and less than or equal to 15, and x is a natural number, which means that it's not going to be any of the decimals between 8 and 15. It's going to be 9, 10, 11, 12, 13, 14, and 15, right? So this symbol right here means that it is in the set of. So let's translate between methods of set notation. So we're going to rewrite each of these sentences in the correct notation, right? So this first one, we're going to write it in words. So remember, this is the bracket says the set of all right, the set of all numbers x such that x is equal to 2 times n, and n is a natural number. Now let's think about what that might mean. Let's say that n was 1. What does x have to be? 2 times 1. So that would be 2, right? Let's say n was 3. If n is 3, then x is 6. I skipped one. If n is 2, x would be 4. So that would be a 2, a 4, a 6. Let's say n is 4, then our x would be an 8. Do you see a pattern emerging? So this indicates that all of our numbers, that our x is going to be positive, even numbers. Okay. Let's say we are wanting to do a set notation in roster notation of the numbers and symbols on the telephone keypad, right? So remember, roster notation is going to be the set here. Numbers that are on there, you've got 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, and there's the star key and the pound key. And I guess if you're looking on your cell phone, you got the dial sign key. That's kind of a symbol, but we're going to ignore that one. All right, so if we were looking at this number line, we are going to, let's put that in set builder notation. So set builder, we're going to have our little bracket, and we'll do x such that, now our x is going to be between -3 and 5. So I'm going to do -3 is x is less than, x is greater than -3 but not equal to, and less than or equal to 5. We don't need to put the qualification that it is like a natural number or anything like that, because it's actually all the points in between them, and so we're just going to leave it just like that. All right, so that's the end of our first video. When you come to class tomorrow, make sure that you are able to translate between different notations and classify numbers in their different types of classifications. Have a good evening.